Hi, welcome to another video by Emily Learning. In this video, let's talk about what you need to know for the chapter on Kinetic Model of Matter. So let's get started. Alright, the best way to know what is tested in the O-level physics exam is by looking at the syllabus. So here we are. This is the syllabus for O-level physics, and here I'm looking at the chapter on Kinetic Model of Matter. Okay, so what do we need to know? Well, let's look at it line by line. So firstly, we need to be able to compare the properties of solid, liquids, and gases. Basically, we know that solids have a fixed volume and a fixed shape. Okay, and the particles are held closely together, not free to move about, and they vibrate about a fixed position. For liquids, the particles are further apart compared to the solid. Okay, but there is still some significant attractive forces between the particles, so therefore the liquid have a fixed volume. Okay, however, it does not have a fixed shape, and it takes the shape of its container. In gases, the particles are very far apart, okay, and are free to move about. Attractive forces between the gas particles are very weak. Okay, so the gases do not have a fixed shape. They take the shape of the container, and they also do not have a fixed volume. They take the volume of its container. Next, describe qualitatively molecular structures of solid, liquids, and gases, relating their properties to forces and distance between molecules and the motion of molecules. So basically, what we need to know is for solid, looks something like this. So the particles are packed closely together. Okay, and because they are packed closely together, they are not free to move about. And they vibrate about a fixed position, they have a fixed volume and a fixed shape. For a liquid, the particles are slightly further apart. Okay. Okay, they can move about within the liquid. Okay, the attractive forces between the liquids are relatively strong. Okay, so the liquid has a fixed volume but do not have a fixed shape. Next, let's look at gases. For gases, the particles are extremely far apart, okay? And the attractive forces between the gases are very weak. So the gas takes the volume and shape of its container. Okay, next let's move on to part C. Infer from a Brownian motion experiment the evidence for the movement of molecules. So in the Brownian motion experiment, what happened is the smoke particles, they are placed in a slide and placed under a microscope. So when we observe the smoke particles on the microscope, the smoke particles are seen moving in randomly in all directions, okay, and haphazardly. So why are the smoke particles moving? Well, this is because the air molecules, which we cannot see, which are invisible, are hitting the smoke particles in all directions and randomly. Okay. Next, let's look at D. Describe the relationship between the motion of molecules and temperature. So when the temperature increases, the solid particles will vibrate more vigorously about the fixed position. When temperature increases, the liquid and gas particles will move more quickly. Okay, and the temperature for a fixed amount of molecules, for a fixed mass of molecules, the temperature is proportional to the average kinetic energy of the particles. Next, explain the pressure of a gas in terms of the motion of its molecules. When we are talking about gas pressure, okay, the pressure due to a gas is created by the gas molecules hitting the walls of the container. Okay, so when the walls of the containers are hit more frequently, the pressure of the gas increases. Okay, part F, recall and explain the following relationship using kinetic model. So a change in pressure of a fixed mass of gas at constant volume caused by a change in temperature of a gas. So what I would suggest, so all these, right, for a fixed mass of gas, what happens is PV over T is a constant. Okay, so what this is trying to say is if um So for part 1, it's change in pressure caused by a change in temperature. So when temperature increases, pressure will also increase. Okay. So if I have a fixed amount of so if I have a fixed amount of gas, when pressure increases, when temperature increases, pressure will also increase if the volume remains constant. That is part 1. Part 2, okay, what it is trying to say is if you have a constant pressure, this means that when temperature increases, volume will also increase for a fixed mass of gas. Part 3 is saying that, okay, for a fixed mass of gas, if temperature remains constant, then when P increases, V must decrease. All right? Okay. Or you can look at it as, just remember that PV over T is a constant. Okay, so if P increase and V remains constant, then T must also increase so that PV over T is a constant, and so on. Okay, so you can remember this relationship uh, by remembering that PV over T is a constant. Okay, use the relationships in F in related situations to solve problems. Okay, so basically what you need to do is, for example, I have an air bubble. Okay, this is the liquid. So this is at the bottom. This is the air bubble. And now the air bubble is going to move up to the surface. And assuming that temperature remains constant, what happens to the size of the air bubble? Okay, so remember, the deeper it is, the higher the pressure. So we know that the pressure here is higher than then when it moves upwards, the pressure of the gas inside this bubble decreases. Okay, and we know that for a constant temperature, when P increases or when P decreases, V must increase. So in other words, as the bubble moves upwards, its volume will increase. So this is what it means by making use of this relationship, this PV over T equals to constant for a fixed mass of gas, to find out the PV and T relationship for a given scenario. All right. So that's it for kinetic model of metal. Okay, to find out more, to learn more about what is tested in other chapters, do check out our other videos. So I'll see you.